let's pick up where we left off from the current slide. There's a lot of material to cover when we talk about the standard normal and normal distribution, so it's good to have a bit of a intermission or a break in this particular video. What we're going to do now is we're going to talk about how you can use the areas and probabilities from a standard normal table, which we've already looked at, in order to answer probability questions or make probability statements for other normal distributions. In order to do this, we're going to need to be able to convert from our random variable to z-scores, and from z-scores back into our standard, or rather our normally distributed random variable. So you will recall from previous discussions that a z-score basically expresses each value of a variable as the deviations from its mean, but then standardized, so the number of standard deviations that a particular value is from the mean. If we take a variable which is normally distributed and we transform it using z-scores, the resulting variable will be a standard normal distribution. Will follow a standard normal distribution. It will have a mean of 0 and a standard deviation of 1. This is very convenient because we can take any standard normal distribution, translate it into a set of z-scores, and answer probability questions using the standard normal table that we have already seen. So we only really need to tabulate the standard normal distribution, not every possible normal distribution. Sometimes we'll want to answer questions where we start with a probability and work our way back to a value of x. This is what in the previous discussion I called an inverse type of a question. And in order to do that, we simply need to be able to take our z-score and get back to x. So we'll know the mean of our distribution and the standard deviation, and we'll just need to know the value of z, and then using this formula, which is derived directly from the value for z-score, but just solving for x, we'll be able to get back to the value of x, so we can answer inverse questions, starting with probabilities and working back to x. But we'll have to do that by working through z, of course. So in answering probability questions for just generic normal distributions, the key is that there's the added step of translating into z-scores and potentially going from z-scores and translating those back into our original random variable. So before we jump in, here's sort of a schematic of what I'm talking about. On the bottom here, I have a random variable x, and obviously is normally distributed. It has a mean of mu, just a generic mean, and a generic standard deviation here. And I start with a value of x on the horizontal axis right here. And I could take that value of x, and I can use the formula for a z-score to standardize it. And you already know that the way that you do that is you subtract the mean from x and divide by the standard deviation. That provides the following z-score on the standard normal distribution. Then, of course, I can use the table in order to calculate this area right here. And once I've calculated that area will be, which is to the left of z, which I look up in the table, will be exactly the same area that's to the left of x in my generic normal distribution down here on the bottom. And if I desire, I can start with z, and I can work my way back to a value of x by taking the value for a z-score and just solving it for x. But the important point here is that z and its associated value of x, or x and its associated value of z, have exactly the same probability, or in other words, area, to the left of the z-score and to the left of the value of x. Those shaded areas, the areas that are shaded in red, are exactly the same areas. That means I can use the standard normal table to answer probability questions about any generically normally distributed random variable. So we'll put this to work with the example of Pepzone. Pepzone is an auto parts company. They supply a lot of different things, but one of the things that they supply is multi-grade motor oil. when the stock of this motor oil drops below 20 gallons, there's a replenishment order that automatically kicks in. The store manager, though, is concerned that sometimes they run out of this motor oil before the replenishment order is fulfilled. And if that's the case, they'll have a stock out and lose sales, and that's a lost business opportunity for Pepzone. So the management has asked us to do a little bit of statistical analysis on the demand over the replenishment period before the replenishment order is fulfilled. So looking at demand over a long period of time, we've determined that demand during the replenishment lead time is normally distributed, and that won't surprise you since we're talking about the normal distribution. And there's a mean of 15 gallons and a standard deviation of 6. So keep these two numbers in mind. They're essential for answering the probability questions. We're going to calculate z-scores by taking various values that our random variable demand during lead time takes on. We'll standardize those by subtracting 15 from them and dividing by 6. So here's a graph of the distribution of lead time, which has a mean of 15 and a standard deviation of 6. And really, this says z, but it's really the variable x. We should correct that here. Just a typo. Okay. So I've got 4 types of probability questions here, which are very similar to the ones that we looked at in the previous video when we were talking about the standard normal distribution. The only added step here is that in each and every case, we need to remember to either transform our data into a z-score and normal and standardize it, or move from a probability to a z-score and then back to a value of x. So very simple. To get started, management wants to know the probability that demand will be less than 4 gallons. We can calculate that by taking the 4 gallons and calculating a z-score. So I take the value of 4, subtract the mean, 15 gallons, and divide by the standard deviation, which is 6 gallons. We know that gives us a z-score, which is equal to minus 1.83. Now that's a z-score, so I can go to the standard normal table and I can look up the area that's associated with minus 1.83. Now, is that the area that we want? Well, indeed it is. If you go back here to my previous graph, somewhere back here to the left of 15, we have 4 gallons. And 4 gallons has a z-score that's associated with it, a z-score of minus 1.83. The area that's to the left of 4 will be the same as the area that's to the left of 1.83 on a standard normal distribution. So all we have to do to answer this question is go to our standard normal table and we will look up minus 1.83. So here we go, minus 1.83. Here is minus 1. And then, oh, actually I want minus 1.8, sorry, minus 1.80123. And the hundredths place gives me 0.0336. I'm looking right here. So 0.0336 is my answer. You can see that that's the answer that I have written down here. So we verify that that is the correct answer. Let's go ahead and answer another type of probability question, one we have to account for the area that's to the right, so we need to remember to take our probability and subtract it from 1. What is the probability that demand is greater than 17 gallons? Well, what we'll do is take 17 and we'll standardize it. We'll subtract the mean of 15, divide by 6, and we'll come up with 0.333. That is the z-score that is associated with 17 gallons. So once I have 0.333, I'm going to look up on the standard normal table the area that's to the left of 0.333. But I have to remember that I've asked for demand which is greater than 17 gallons. That means that I want a right-tailed area in the distribution, so I have to remember to subtract my answer from 1. Again, just to show you a picture, whenever you get lost, it's always really helpful to draw a picture in these cases. What we have here is we have 17 gallons. Clearly 17 gallons is to the right of 15 gallons. just like 0.333 is to the right of 0 on the standard normal distribution. And what this question is asking for is it's asking for the area that's to the right. So what I need to do is take 17, calculate a z-score for 17, look up that area, which will be equivalent to this area in the graph, which is to the left of 17, but I know that the area under the curve adds up to 1, and so I'll take the answer, I will subtract it from 1, and I will have my result. So let's go ahead and take a look at the standard normal table. My z-score is 0.333. So going to my standard normal table, let me erase the marks that I made on the standard normal table before. I will look up 0.333. So here's 0.3 right here, and here's 0.03. So that is going to lead to an answer here of 0.6293. So I look up 0.6293, but I have to remember to take that 0.6293 and subtract it from 1. So it's 1 minus 0.6293 because I'm looking for demand which is greater than 17 gallons, not demand which is less than 17 gallons. The answer is 0.3707, or 37% roughly of the time. Demand during the replenishment period will turn out to be greater than 17 gallons. So again, I've correctly calculated the area that is to the right of 17 gallons in my original distribution. Let's go ahead and do a couple more, just for the sake of completeness. Okay, for the next one, we'll erase the marks that we made on both of these documents. We will come back. We will talk about a case where management wants to know the probability that demand is between 4 and 17 gallons during the replenishment period. So rather than looking for the area to the right or the area to the left, we're looking for the area that's in between two z-scores, between the z-scores that are associated with 4 gallons and 17 gallons. So 4 gallons we know is back here to the left of the mean. We had a negative z-score for that. We had a positive z-score for 17 gallons. That was maybe here somewhere. I apologize that it's just not easier to write well with this tool in PowerPoint, but it's the best tool that I've found so far. So, but what we're looking for is the area that's in between. It's kind of in between those two. Make that a little straighter. It's tough. So the area that's in between those two values. So what I need to do is I need to take 17 and find a z-score, which I've already done, and 4 and find its z-score, which I've already done. Look up the areas that are associated with these two z-scores and take the difference between the two. So take the area I look up in the table for the z-score associated with 17, and from that I'll subtract the area that's associated with the z-score for 4, and I'll be left with this area that's in between 4 and 7 in my original distribution. In other words, taking this whole area here and subtracting out this area for the z-score of 4 and being left with the area that I desire. So I really have already done all of the table looking up that I need to do. I know that the area that's associated with a z-score of 17 gallons to the left of 17 gallons is 0.6293. I calculated that in my second question. I calculated the area that's to the left of 4 gallons here in the first step, and that was 0.0336. So I just have to take the difference between the two. And 59.5% of the time, demand during the replenishment period will be between 4 and 17 gallons. Finally, I'm going to show you how to solve an inverse type of question. Here we're going to start with a probability of 20%. So management wants to know what value of x is associated with a probability of demand that's less than or equal to 20%. So we have less than or equal to this time, so we don't have to worry about subtracting the 20% from 1. We can just work with the 20% value. Here's the strategy. We're going to go to the standard normal table, and we're going to look up the z-score that's associated with 0.2. So we're going to look in the middle of the table for 0.2, and then we're going to work out and find the associated z-score. Once we've found the associated z-score, we're going to translate that back into a value of x using the formula that we've already covered, which is derived from the the formula for calculating a z-score. We'll take the mean, which we know to be equal to 15, and the standard deviation, which we know to be equal to 6, and we'll plug in the z-score that we find from the table to answer the question. So here we've got a z-score of minus 0.84, which I've already done. Let's verify that I found that correctly. Let's look for 0.2 in the middle of the table and verify that the z-score associated with it would be minus 0.84. So minus 0.84. My negative numbers are on the left. Here's minus 0.8, 0, 1, 2, 3, 4. That's it right there. Right? 0.2005. That's close enough for me. So that's minus 0.84 in the hundreds place. So minus 0.84. Again, what I did, was I searched through the table, which sometimes can be a little bit of a pain, which is a good reason for using computers to do these things, which I cover fully step by step how to do these things in Excel in your notes, and I expect you to know how to do these things in Excel. But I started here and I looked for this number, and then I read out to the margins to get the minus 0.84. Once I know the minus 0.84, I can just plug it into the formula for calculating x. I know that the mean is equal to 15, the standard deviation is equal to 6, and I just looked up the z-score for which 20% of the values are smaller in a standard normal distribution. So to get back to the value of x, I just do this calculation and I come up with 9.96. That means that 20% of the time, demand during the replenishment period will be less than or equal to 9.96 gallons. So it's important to be able to do these types of calculations and interpret the area under the standard normal curve and know how that associates to calculating probabilities for any regular normal distribution. I also think it's very important when you get to the end of one of these questions to state the answer in a way that would make sense to somebody in business, right? Somebody who's going to actually use this information. So the answer isn't just 9.96. The answer is that 20% of the time, demand during the replenishment period will be less than or equal to 9.96 gallons. Try to put all of that context in there when you answer these questions. I'm going to ask you to work through a couple of questions on your own here for going back and forth between a standard normal, a normal distribution, and answer a couple of probability questions. So I'd like you to open up the document Chapter 6 Worksheet for Video Lecture Checkpoints and answer a couple of questions so that you can verify for yourself that you know how to do these very, very important calculations. If you run into trouble, I recommend that you go back and watch both this video and the previous video again until you really have these techniques down. Knowing the information that we've covered here is going to make what we do next when we talk about sampling distributions and ultimately move on to things like confidence intervals, hypothesis testing, and regression analysis. It's going to make all those topics so much easier for you if you can practically do these types of calculations in your sleep.